Okay, so at the very beginning of this unit, we talked about the 6 different reaction types that Gilbert Public Schools focuses on. I'll do my best to really quickly go through these in this video, but your best shot for this is to look back over those notes and figure out the patterns that you're seeing within those notes. I should have posted the PowerPoint that we went over. I would suggest watching that again. Otherwise, just watch this here. So the first type that we have is a synthesis or combination reaction. When you combine something together, you're bringing things together to make one thing. So I like to think about synthesis kind of like a marriage. So if you have hydrogen plus oxygen coming together, getting married to form water, see how that's 2 separate entities becoming one entity? That would be synthesis or combination. So when you see lots of things coming together to end up in one product, that would be called a synthesis or combination reaction. Next, we have something called a decomposition reaction. So you guys should know the root of this, right? Decompose. When something decomposes, it breaks down. So this would be the exact opposite of synthesis or combination. For example, if you had water that broke down into separate hydrogen and oxygen, that's decomposition, because we start with one thing and we end up with 2 separate entities. Okay? Oops, I'm going to do something even faster here. Boom. All right, next thing we have is a single replacement reaction. And my students will know my famous story here, where basically something happened where I was talking to a guy, my good friend swooped, stole the guy from me on my birthday, and I was left all alone and single and sad. Okay? It's a silly story. It's a true story. But the point of it is that someone starts out single, and they go ahead and they swoop on someone and try to steal a partner. And then that person who had a partner ends up like sad and alone. So for example, right here with this reaction, iron is all alone. They're single. They get their eyes on chlorine because chlorine looks attracted to them, and they decide to compete with silver right here to try to steal chlorine. And so what ends up happening is that iron ends up getting with chlorine and making a cute little compound there, and then silver is left all sad and single. So the trick to a single replacement is, do you have someone single at the beginning and someone single at the ending, and a partnership where they got switched, okay? That is different from double replacement, where someone's partnered with someone at all parts of this reaction, okay? It's not like here where someone gets kind of booted out of a relationship. And by relationship, I mean by a chemical bond or whatever. Okay, so for example, right here, we could say NaCl plus FeNO3. I'm making these reactions up in my head, by the way. Don't come at me if these are like not real or whatever. I'm just trying to give you the purpose of it. Okay, so right here, look. Sodium starts out with chlorine, but then sodium ends out with NO3. And iron starts with NO3 and then ends with chlorine. I like to think about like country dancing right here, because there's 2 sets of partners and they go ahead and they twirl around, they switch their partners, but everybody ends up with a partner. Whereas with single replacement, someone is left sad and lonely and by themselves. Single. All right, the next type of reaction is a combustion reaction. These ones are kind of tricky because there's lots of different types of combustion reactions that you can see. But in Gilbert Public Schools, the 3 things we're looking for is oxygen as a reactant, and then having water and carbon dioxide as our products. So anytime you see a combo of these 3 guys, you need to know, boom, that's combustion. last but not least, we have neutralization. So neutralization reactions are where you have an acid plus a base, which yields a salt plus water. I will tell you right now, I've watched my students, a lot of people will get this wrong. They'll get the things confused because they'll just see water and automatically assume combustion, because that was one of the ones from the last one. But you have to be careful and know that a salt is really just another word for saying an ionic compound. Okay? So just because there's water in the ending doesn't necessarily mean that it is neutralization or combustion. You have to be able to tell what else is with the water. CO2 is not a salt, right? That's a covalent compound, so that's not going to happen. A hint for you is that a lot of acids are going to start with an H. Okay, so if you see something start with an H on the left side and then you see an ionic compound in water at the end, chances are that's neutralization. Quick note, double replacements. Neutralization is technically like double replacement, but this is just a more specific type. Okay, so those are the 6 types. If you need more help, go back and look at your notes, at your practices, at the PowerPoint.